The stabilization system is performing optimally.
Confirmed. All parameters are well within limits.
Daylight reflects evenly across the fuselage, creating the feeling of an endless straight line.
The aircraft does not need sudden direction changes, but maintains its trajectory like an unbreakable rule.
There is no sudden thrust or sharp acceleration, only a continuous, gentle motion.
Air flows across the wing in a steady stream, as if everything had been calculated beforehand. Every detail of the aircraft is designed to minimize risk to the lowest possible level.
Stability is not just a feeling, but a design objective from the very beginning.
Behind the terminal, the aircraft is towed into a vast maintenance hangar under cold white lighting covering the entire space.
Confirmed. The stress test results match the projection.
All right, marking this section clear.
The readings on the starboard engine cowling are consistent with the last check.
Good. Let's verify the pressure systems near the landing gear next.
Hydraulic fluid levels checked.
Checked.
Tire pressure verified.
Verified.
All access panels secured and locked. Reflections on the aircraft surface reveal tiny details unseen during flight.
Check the thermal readings again on the tablet. Rerunning the scan now, same result. The deviation is within tolerance, confirmed visually. All right, let's sign off on this section.
In that space, there is no room for even the smallest error.
A metal joint is examined again, even without visible defects.
Did you notice the discrepancy on the fuselage joint? The readings on the turbine bearings are inconsistent.
Agreed. Let's open this access panel and inspect the lubrication system before we sign off.
There is no warning signal, yet a sense of imperfection remains in the air.
All data is rechecked under different conditions before acceptance. Caution stretches each second, as if time no longer matters. All of this raises a question that no one speaks aloud.
G-force levels are critical. Trajectory is braking.
We're losing altitude rapidly. Command override engaged.
The motion is no longer smooth, but filled with sudden direction changes under intense acceleration.
The pressure is spiking on the starboard engine.
I see it. Reroute auxiliary power now.
We're losing stabilization control.
Warning light 47 is critical. We have unstable telemetry.
Override confirmed. I'm taking manual control of the descent.
I need eyes on the telemetry spike now.
Confirming new trajectory. Stabilize the main array. Air is no longer smooth, but violently torn apart by speed and force. The wing does not remain stable, but constantly shifts angle to adapt. Every movement carries risk. but is necessary for survival.
There is no time for repeated checks. Decisions must be made instantly.
Flexibility becomes the key to survival instead of stability. Civilian aircraft maintain course to ensure safety for hundreds of people on board. Combat aircraft break their path to survive in dangerous environments.
One side minimizes risk to the lowest level, while the other accepts risk to maximize performance.
One prioritizes smoothness, while the other prioritizes rapid response.
One must predict every situation, while the other adapts to the unpredictable. One controls every detail, while the other uses constant change. One cannot afford error, while the other must tolerate controlled deviation. One extends system lifespan, while the other consumes it rapidly for immediate effectiveness. One remains stable as a rule, while the other breaks rules to survive.
These two philosophies do not oppose each other, but exist for entirely different purposes. The civilian aircraft remains unchanged in appearance, but its meaning has shifted.
The combat aircraft continues to surge through the sky in relentless motion. The male engineer understands that every design begins with a different question.
There is no single standard for all aircraft.
The efficiency metrics here are impressive.
I agree. We should review the data from the previous shift as well.
No design is absolutely perfect, but only suited for its mission.
Stability is not weakness, and flexibility is not danger.
Each choice is the result of the environment it must survive in. The sky does not change, but how humans fly within it is completely different.
And that difference creates two design philosophies that can never be the same.